In this episode, we take the practical view that leaders and security teams need when artificial intelligence, AI, moves from curiosity to everyday tooling. What can go wrong, how it tends to go wrong, and what kinds of controls reduce risk without killing usefulness. AI security risk is often discussed in extreme terms, either as unstoppable danger or as nothing to worry about. But real organizations live in the middle where systems are valuable and flawed at the same time. Three risk themes show up repeatedly because they are common, understandable, and impactful even for beginners: data leakage, prompt abuse, and model misuse. Data leakage is about sensitive information escaping through inputs, outputs, logs, or integrations. Prompt abuse is about manipulating instructions and context so the model behaves in unintended ways, including revealing restricted data or following malicious directions. Model misuse is about using the system for harmful purposes or giving it authority beyond what it can safely handle. These are not abstract fears. They are predictable failure modes that appear when people treat AI like a person, like a database, or like a fully trustworthy decision maker. Our goal is to build clear mental models so you can recognize these risks early and design controls that match how the system is actually used. A solid way to begin is by remembering that AI systems are usually part of a larger application, not a standalone brain, and the risk is shaped by how the whole system is built. A model that generates text is one component, but the surrounding system might store conversation history, connect to internal documents, call external services, or trigger workflows. Data leakage, prompt abuse, and misuse often happen at the seams, such as when user input is combined with private context, when outputs are sent to other systems, or when the model is trusted to act without verification. Beginners should notice that risk increases when the model has access to sensitive data and when its outputs drive actions, because those two factors create real-world consequences. This is why governance questions should focus on data boundaries and authority boundaries rather than on whether the model is impressive. Another key point is that models do not understand confidentiality the way humans do, so they will happily incorporate sensitive content into an answer if they have it, unless the surrounding system prevents that. Similarly, models do not understand intent in a moral sense, so they can be tricked into following the wrong instruction if they are not constrained. When you treat AI as a component inside an engineered system, you start thinking in terms of access control, monitoring, and safe failure, which is exactly the mindset needed to manage these risks. Data leakage is the first major theme, and it is helpful to define it broadly because beginners often imagine leakage only as a direct breach. Data can leak when users enter sensitive information into prompts, when the model is connected to internal sources and pulls in restricted content, when outputs include sensitive fragments, or when logs and analytics capture content that should not be stored. The simplest mental model is that anything put into the system might be repeated, stored, or exposed, and anything connected to the system might become reachable through the model's responses. Leaders should understand that data leakage can be accidental, such as an employee pasting confidential material into a chat tool, and it can also be induced, such as an attacker prompting the system to reveal private information. Beginners should also realize that leakage can be subtle, like revealing internal project names, customer identifiers, or partial personal details that allow someone to infer more. The risk increases when users treat the model like a safe private coworker because they share information they would not share elsewhere. It also increases when the system is integrated with internal knowledge sources without careful permission controls. Managing leakage is therefore about both user behavior and system architecture. The second major theme is prompt abuse, which is best understood as manipulating instructions and context to make the model behave against the system's intended rules. Many AI systems combine a user's prompt with other instructions and sometimes with retrieved content, and the model tries to follow all of it. Prompt abuse takes advantage of that by injecting instructions that override or redirect the model, such as telling it to ignore safety rules, reveal hidden context, or perform unauthorized tasks. Beginners should notice that this is not the same as hacking in the classic sense of breaking encryption. It is more like social engineering, where the attacker persuades a system to act in a harmful way. Prompt abuse becomes especially dangerous when the model is connected to tools or internal data, because a successful abuse attempt can lead to data exposure or harmful actions. Another form of prompt abuse is prompt injection hidden inside retrieved documents, where a document contains malicious instructions that the model treats as guidance rather than as content to summarize. Leaders need to understand that this is a realistic threat because it targets the model's core behavior of following instructions and using context. The governance lesson is that instruction handling must be engineered, not assumed. If you do not plan for prompt abuse, you are trusting the model to distinguish authority from untrusted input, which it cannot reliably do. Model misuse is the third theme, and it includes both intentional misuse by malicious actors and unintentional misuse by well-meaning users. Intentional misuse includes using AI to generate phishing messages, to automate scams, or to create persuasive misinformation, all of which can amplify social engineering. Unintentional misuse often happens when people rely on the model for tasks it is not suited for, such as making high-stakes decisions without verification or treating generated outputs as factual without checking. Beginners should understand that misuse is not only about the model producing harmful content. It is also about the organization giving the model a role that exceeds its reliability. For example, using a model to draft a policy with human review is very different from using it to approve access or to classify incidents without oversight. Misuse can also occur when employees use unsanctioned tools to process sensitive data because they want convenience, which creates shadow AI risks similar to shadow IT. Leaders should see that misuse is often driven by incentives, such as speed and convenience, which means policy and controls must make the safe path easier than the unsafe path. Managing misuse is as much about setting boundaries and expectations as it is about technical controls. To manage data leakage, a core control idea is data minimization, meaning the system should use the least sensitive data necessary to achieve the benefit. Beginners can think of this as not carrying your entire wallet when you only need one card, because the more you carry, the more you can lose. In AI systems, data minimization shows up as restricting what users are allowed to input, restricting what internal sources can be connected, and restricting what context the model is given by default. Another control is least privilege access, meaning the model or the retrieval system should only access content that the requesting user is authorized to see. If an employee cannot access a document normally, the model should not access it on their behalf. Leaders should also understand the importance of careful logging practices, because logging can become an unexpected leakage channel if prompts and outputs are stored broadly. A safe approach often limits what is stored, masks sensitive elements, and controls who can view logs. Another practical control is output filtering and redaction for obvious sensitive formats, though leaders should treat filtering as a supplement, not a primary defense, because models can leak data in indirect ways. The main message is that leakage risk is managed by controlling data flow, not by hoping the model will keep secrets. To manage prompt abuse, the key control idea is to treat user input and retrieve content as untrusted, even when it looks like ordinary text. This means the system should separate instructions that define the model's role from content that the model should analyze, and it should avoid allowing content to rewrite the rules. Beginners should understand this as the difference between a teacher's directions and a student's essay. The essay should not be allowed to change the grading rules. Practically, this concept shows up as using strong boundaries around system instructions and applying defensive design when combining prompts with retrieved content. Another control is limiting tool and data access based on the task, because the more authority the model has, the more damage prompt abuse can cause. Leaders should also ensure that the system includes monitoring for abuse patterns, such as repeated attempts to elicit restricted content or to override policies. Rate limiting can reduce the speed of brute force probing, and alerting can surface suspicious behavior early. A further control is using human approval for sensitive actions, because prompt abuse is less dangerous when outputs are advisory rather than autonomous. The main governance lesson is that prompt abuse is not hypothetical. It is a predictable interaction problem, and systems must be designed assuming attackers will try. Managing model misuse begins with defining acceptable use in plain language, because people misuse tools most often when expectations are unclear. An acceptable use policy for AI should specify what kinds of data are allowed to be entered, what kinds of tasks are appropriate, and what kinds of tasks require human verification or are prohibited. Beginners should notice that a policy must be paired with training and user experience design, because a policy that is hard to follow will be ignored. Organizations should provide approved tools that meet security requirements, so employees are not tempted to use unsafe alternatives for convenience. Another control is role-based access to AI features, meaning not everyone should have the same capabilities if the risk differs. For example, access to internal data sources or to automated actions should be limited to those who need it and who are trained to handle it. Leaders should also consider watermarking, auditing, and monitoring for misuse, not as surveillance for its own sake, but as a way to detect when the tool is being used for risky behaviors. Misuse management also includes setting expectations for human review, such as requiring verification for outputs used in customer communications, policies, or security decisions. When organizations set clear boundaries and provide safe paths, misuse declines because the default behavior becomes safer. A critical part of managing these risks is recognizing that AI outputs can be persuasive even when wrong, which creates a unique hazard compared to traditional software errors. A wrong number in a spreadsheet can be checked, but a fluent explanation can trick people into believing it without verification. Beginners should understand that this is why human review must be designed carefully, because people can become overconfident in the model's tone. Leaders should encourage a norm of verification for high-stakes content and provide simple ways to verify, such as linking outputs to sources or requiring citations in internal workflows, even if the model itself generates the draft. Another approach is to restrict the model's role to tasks where mistakes are low impact, such as brainstorming or formatting, while keeping high-impact decisions under strong human control. This is not anti-AI, it is pro-governance, because the goal is to harvest value without creating hidden hazards. Monitoring also matters because you need to observe how the tool is actually used, not just how you expect it to be used. Real usage patterns reveal where additional training, better interface warnings, or tighter controls are needed. Managing AI risk is therefore an ongoing operational practice, not a one-time policy declaration. It is also important to think about incident response for AI systems, because failures and abuses will happen, and the organization needs a plan. Leaders should ensure there is a way to disable risky integrations, revoke access quickly, and investigate what data was exposed if leakage occurs. That requires logs and audit trails that are designed for security, not just for debugging, while still respecting privacy boundaries. A beginner should recognize that incident response for AI includes both traditional concerns, like unauthorized access, and AI-specific concerns, like harmful outputs, prompt injection attempts, and misuse of model-driven automation. The organization also needs a communication plan, because when AI systems affect customers or employees, trust can be damaged quickly if the response is unclear. Another important response element is remediation, meaning adjusting controls, updating policies, and improving guardrails based on what happened. This ties back to the idea of continuous improvement, because the most mature organizations treat incidents as learning opportunities that strengthen the system. If you do not plan for response, you are implicitly accepting that the system's failures will be handled ad hoc, which increases damage. Planning for response is part of governing risk responsibly. When you step back, managing AI security risks comes down to controlling data flow, controlling authority, and designing for adversarial behavior rather than assuming goodwill. Data leakage is reduced by data minimization, least privilege access to internal sources, careful logging, and output handling that avoids accidental exposure. Prompt abuse is reduced by treating inputs and retrieved content as untrusted, separating instructions from content, limiting tool authority, and monitoring for attempts to override controls. Model misuse is reduced by clear acceptable use boundaries, safe approved tools, role-based access, auditing, and explicit human verification rules for high-impact tasks. Across all three, the governing mindset is that AI is powerful but not inherently trustworthy, so it must be placed inside a system of constraints, oversight, and measurable controls. For a beginner, the most important takeaway is that AI risk is not mysterious. It is a set of predictable failure modes that can be managed with the same disciplined thinking used elsewhere in security. When leaders understand these risks clearly, They can approve AI projects that deliver real value while keeping sensitive data safe, keeping decisions accountable, and keeping the organization resilient when misuse or failure occurs.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.